everyone, and welcome to this technologycatalog.com webinar. Today, we'll speak about isolation technologies, and I'm happy to introduce Lynn from Izomax, Neil from Stats Group, and Evert from Valvetight, who will be the three presenters this morning. In a sec, I'll hand over to Lynn for the first presentation, because we actually have three presentations today. But before I do that, let me just let you know that if you have any questions during the presentation of one of the presenters, you can just type your questions in the chat, and we will pick up all questions at the end of the session. So we'll have three 15-minute presentations, and then the last 15 minutes we've reserved for the Q&A. If you have a question for one of the presenters in particular, please, when you type the question in the chat, just say for which company or which presenter you have the question. But I can also imagine after you've listened to the three presentations that maybe it's a general question, and then we'll decide who can actually answer it best. So without further ado, I would like to hand over to Lynn. Enjoy the presentations today, and I'll see you back in the Q&A. Lynn, over to you.
Yeah, you can see my screen. Great. Thank you, Vincent, and good morning all. And many thanks for joining today's technology isolation webinar. As mentioned, my name is Lynn Lyon, and I am representing Izomax. Today, I will introduce you to our proprietary technology, the AOGV, the mechanical isolation system, which delivers positive isolation on a live line. And here it is in its blown up view. This is the AOGV, and what we're seeing here is it being assembled and broken down into its various segments over a 3-flange pair. So what it does, it essentially converts a flange pair into an isolation point. So you assemble it, as I've mentioned, in a particular sequence, and essentially the AOGV is a pressure housing which goes around the outside of the flange. It has elastomer seals, which we can see in red. These are the points of which seal around the outside of the flange. We have what we call integrity clamps either side of the flange, and these are compressed together with our integrity clamp bolts. So this is what allows it to seal on the outer circumference of the flange. So we compress either side of the integrity clamps together while keeping the original gasket leak tight. We are then able to remove each and every one of the flange stud bolts and replace them with our own AOGV stud bolts. So we are now sealing on the outer circumference of the flange pair, as well as in each and every one of the flange bolt holes. This then allows us to gain access safely in between the flange for us to then insert the spade while the line is pressurized. So what the AOGV then creates is a zero energy zone for maintenance, intervention, inspection, modification work to then be carried out while production is running with minimal downtime and without needing to wait on a shutdown. We have many uses of the AOGV. We have been around the globe delivering this technology to many operators. The applications include and are not limited to changing out of gaskets, valve replacements. We are seeing an uptick, so an increase in the number of tie-in applications which the AOGV is being used for. It's also ideal for spool replacements or removing a spool in its entirety or an old pipe, similarly to what we see in decommissioning scopes. And of course, because we deliver positive isolation, this is the safest means of isolating. You're then able to safely access for vessel entry, for clean out and maintenance. What the AOGV eliminates, so you avoid having to carry out any hot work whatsoever. It is a temporary solution, so it's built around the flange pair, and we insert the blind, and once we're done, we retract the blind, we replace it, we replace the gasket with new bolts, and the pipe work is left as was found. Again, as I had mentioned, you can use the AOGV outside of a turnaround, so you need not wait until that time comes round. You can do emergency repairs and intervention, as well as planned scopes out with a shutdown, which of course is only going to increase your asset uptime because you're not having to kick that can down the road, waiting for these critical intervention scopes to take place. While the AOGV can be used and is sometimes used inside of a turnaround or a shutdown, what we are typically seeing is a reduction in the operational schedule due to the efficiencies of using the AOGV. And of course, because we are eliminating the need for a shutdown, we're reducing downtime. The AOGV allows the processes of your system to continue to flow, and of course, your cash flow to continue. A snapshot now of the AOGV Izomax where we've been. We have delivered over 280 successful isolation scopes to date. As I said, that's taken us across the world on 5 continents. We are trusted by over 30 customers, many of whom are within the top 10 super majors within the oil and gas industry, and many of those which the AOGV is already an approved technology for. We have fleet stock available of 60 different tool sizes and class combinations. So for pipe diameter, that starts at as small as 1 inch up to 36 inch. And we have 150 and 300 and various other class sizes in between. Our operational parameters, the maximum temperature which we go up to is 200 degrees Celsius at this moment in time. We are working with research and design to introduce a super high temp AOGV, so watch this space. The pressure we have gone up to so far, this is not a ceiling, this is 220 bar, and critically and most importantly, we have had 0 HSE incidences since the AOGV's very first run back in 2018. And of course, that is a metric we are incredibly proud of. And as today's session, of course, is a case study technology webinar, I wanted to look at one particular scope we had completed the summer of last year. This was with a large operator in the North Sea, and it involved 3 different tool sizes. So this was working to isolate 3 separate systems of 3 separate sizes. So we were working on 2 heating medium systems and a gas turbine waste heat removal unit. So this included 12-inch 300, 14-inch 300, and 18-inch 300. The challenge for the operator was the fact that they had 12 critical valves which were passing. These had to be isolated across each of the 3 aforementioned systems in the various line sizes, while dealing with a compromised accessibility to each of the valves which needed to be replaced. So I will talk you through how we approach the operation on their utility system. The operational temperature of the medium was up to 150 degrees Celsius, so relatively high temperature, and the range that we were seeing in terms of operational pressure was 10 to 17 bar. And here, of course, is a lovely photograph taken at site against the 12-inch 300 tool. So what the operator was looking for was the ability to replace all 12 valves while maintaining the system's online capability. So again, to avoid shutdown, to ensure the integrity of the system was maintained with zero HS&E concerns. I'd already mentioned the temperatures which we were operating within. And of course, equally as critical is the fact that the operator was looking at having to drain out the entire heating medium system to replace the valves. So by utilising the AOGV, we also avoided draining and the storage of the complete pipeline medium. As I had said, this involved quite a number of valve replacements as well as 3 fairly sizable tools. So we had spent a lot of time with the client, collaborating at how we would approach this operationally. And to begin at the very start, we had visited site and conducted a site survey. That is also a service which Izomax provides, and that means we're capturing and gathering all the measurements and data points to look at the feasibility of the AOGV, as well as the suitability of each isolation point and the tooling requirements. So all 3 tools was a engineered fit for purpose solution. So we had modified 2 of our fleet stock tools, as well as built 1 brand new to order. I had mentioned the restricted space around some of the valves. So we had also invited the client to attend Izomax HQ. That is based in Stavanger, Norway. And we had set up a mock-up rig site, including some mock-up spools and valves to mimic as best as we could the site conditions. And the client then was there to witness the build, setting the spade, disassembly of the AOGV, running various cycle tests, as well as looking at the lifting considerations and the access points and how that would all marry together to deliver a well executed and considered approach. The approach was done in 3 phases. So each of the heating medium systems were worked on alternatively. So while the 4 valves were being replaced on one, the other, so the A and B, so the other heating medium system was kept online, and vice versa. The scope also included inspection of the ancillaries, and critical cleaning was also performed of various parts of it. And the third approach involved the 4 valves, the inlet and outlet, 2 of each valves being replaced on the gas turbine waste heat removal unit. Again, I had mentioned the full and thorough collaboration with the client that had began at initial engagement straight up into project execution, as well as the handover post project. And here was the outcome. Again, some more photographs taken at site. The project went superbly well, all to time. I think it was even delivered ahead of schedule. So the efficiencies and the critical discussions and preparation, which Izomax and the client had done at HQ, all fed very well into the site execution. 12 valves replaced successfully online with 0 HSE incidences. Of course, using the AOGV, we avoided having to drain the complete heating medium systems, and critically, no shutdown was required. And by utilising the AOGV, the client had avoided what would have been a 10-day full facility outage. And finally, that was a high-level overview of one of our many projects. As I'd mentioned, we've delivered over 280 of these across the globe with many different applications, operational approaches, and tool configurations. And so please, if and when you have time, I do encourage you to visit the Izomax website. We have a plethora of information on it, including our interactive system whereby you're able to look at the refinery and the various points and applications which are involved within it and how that may look to you, and case studies and applications are there to explore. So please, as and when you do have a moment, I do encourage you to check that out. And of course, I'm here for any questions at the end.
Thank you very much, Lynn. And that's within the time slot, so that's great. So we're nice on track. So for those of you that joined late, before I hand over to Evert from Valvetight for the next presentation, in case you have any questions for Lynn already, please type them in the Q&A chat. You will not be able to see the questions from others, but we will pick them up at the end of the session for all the speakers. So Evert, if you can share your presentation on the screen, I'll hand over to you. Yeah, perfect.
Okay. Thank you all for joining today's session. Also on behalf of myself, my name is Evert Witkop. I'm the Commercial Director of Valvetight. And today I would like to tell you a little bit more about the Valvetight's DBB saver, which our client typically uses to work safely behind passing valves. So typically the DBB saver can be used for process isolation of any type of essence using valves. And we face that any kind of mediums, so it is independent of medium. So we have worked in mediums like natural gases, like H2S, hydrogen, but also in liquids like naphtha, crude oil, and also multi-phase applications. And even about, we also have been working when we have liquids becoming gaseous under atmospheric conditions like LNG or LPG. As said, any types of assets from pig traps to plants to pipelines, anywhere we have a situation where leaking valves are causing problems to work safely behind the leaking valves. So on the left bottom side, you see a schematic of a gas compressor station, and it's a typical example of our customers working in a double block or bleed configuration or single valve isolation. And when they want to isolate the process and the valves are leaking in a double block and bleed isolations, it's impossible to work safely behind these leaking valves. So what you can do is that you close a valve more upstream, and in this particular case, this will cause the whole gas compressor building to shut down. Or and you have to depressurize the whole plant or the pipeline, causing a major outage, obviously. And the other option you have is to postpone the work. Again, costs you a lot of money because all the operators are already on site and causing delays, which are not ideal, obviously. Or you can grease the valves, but that's also very temporarily solution. And after time, the grease will be pushed out by the pressure and again causing leakage of the passing of the leaking valves. So our solution is that we create a vacuum in the bleed area. And by creating this vacuum in the bleed area, we create reversing flow over the second valve. By creating this reversive flow over the second valve, then it's physically impossible to have gas passing the second valve. So we always have a safe working area. The DVB saver, we typically connect to the bleed in this example. And then while it's connected, it will create, it will maintain, it will control, and also continuously monitor the vacuum. So at all times, we know we have a vacuum, and at all times you can guarantee that we can safely work at the safe work area. So we say it's a new step in reaching the highest level of safety. This is also shown in an animation video, but I will not show it today. This is just mentioned here so you can look afterwards after the meeting. We will share our presentations so you can look it up and have a little bit more information via our video, but it will take too long for today. It was worthwhile mentioning. Actually, this is a screenshot from the video to giving you a little bit an idea how the DVB saver is implemented. This is a double block and bleed configuration where both valves are closed, but still you see gas passing the valves. We are connected to the bleed, and we are creating a vacuum by using our DVB saver, and then we will vent the gas in combination with the nitrogen, because the DVB saver is driven by nitrogen, or sometimes it's compressed air, using the nitrogen from the plant or nitrogen quads. And then the mixture is vent off as non-flammable mixture. If you look to the right side of this double block and bleed configuration, by creating a vacuum, we might suck in some air if the second valve is also leaking. And then by creating or sucking in some air, it's physically impossible to have any gas passing the second valve. So making sure downstream of this valve you can work safely. We can vent, by the way, in any location. You can vent at this location where you see it right now, but if the client likes us to vent 40 meters further away, we can add a few hoses to the system and you can vent off the mixture there, or we can tie into the flare system if that's required by the customer. And you can see it's a very small machine, the DVB saver. It's a small footprint, and it's completely ATEX certified. It's also HAZLOC Class 1 Div 1 certified for the American market, so that's also possible if that's required. The DVB saver is equipped with all kinds of alarms. When there's an increase, for example, of the leak rate or a decrease of the leak rate, or in case the nitrogen is being blocked or is dropping, we always have a redundant hose connected to the DVB saver in case one of the hoses or the nitrogen is not there anymore. That will also raise an alarm. The machine can also be equipped with SIM cards, so you can send the alarms also to the control room. The machine is one size fits all, so it will also be possible independent of the pressure class or independent of the pipeline size to connect it to any kind of bleed area. As long as we can create a vacuum, the machine can be used as such. So I'm just showing this as a double block and bleed configuration, but it is also possible for a single valve isolation, but it needs to have two seats, obviously, because with the second seat, we can create a vacuum in the body cavity. Typically, we are connected to the vent in the cavity or in the drain. And in this particular case, you can see that we are connected to the drain. Again, if you create a vacuum, no gas will be physically possible to pass the second seat of this valve. So using the DVB saver, we add value because we are adding extra layers of protection to the prevention side of the bow tie. And because we can mitigate the leakage of the first block valve seat, and we are online measuring the leak rate. It constantly is being measured by our tool, but it will also, as said, give you pre-alarms of leak rate increases or in case the nitrogen is dropping. The control room will get the alarm as well. And because we are working with the DVB saver, it's every second measurements, which is controlling and monitoring the vacuum constantly. So it's no human interventions, also built to have less chance of failures, of human failures. So the remaining risk is alarm, as low as reasonable possible, and lower than ever before. Same as the Izomax application, the remaining plant or platform or pipeline stays in production, so your uptime is being optimized. And also the minimum gas loss and gas emissions you will have it there. The DVB saver, I forgot to mention, it will register the gas emissions which you can use for your greenhouse gas emission report. It's automatically being supplied after the job. So using the DVB saver, you can keep on working and maintaining on your assets without any delays. And also you even don't have to replace the valves because we showed that with leaking valves you can still create a safe working area. I'm not sure if you're familiar, but here you see a screenshot of the health and safety governance created after the pipeline Alpha accident in the North Sea, where the #1 level of isolation is the positive isolation, which Lynn already mentioned earlier. But the second level is the proved isolation. And proved isolation takes care of an isolation using a double block and bleed or a single block and bleed. And we say with using the DVB saver, you create the highest achievable safety level of isolation, because then you have a double block and vacuum instead of double block and bleed. So using and working with DVB saver, you will achieve the highest level of the proved isolation. Also some examples of applications done in the past. On the left top side, you see an offshore gas application on the biggest flow of the biggest FLNG in the world. This application is also including on the right next to the DVB safe, you see a knock-out vessel, which is used to separate the liquids from the gases. The liquids will be drained to the therefore dedicated area, and the gases will be fanned off. This was offshore. On the right top picture, you see the application which was done onshore, which you see on the left side the DVB saver, then the knockout vessel, and then the vaporizer, which is used for an LNG application. So that's also possible to work in LNG areas of LNG applications using a vaporizer. At the moment, we are using this application. We have 2 of these machines running at the same location, somewhere in the Netherlands. On the left bottom side, it's other interesting feature of the DVB saver that we can connect to multiple bleed points. So with one DVB saver, you can connect to 4 or 5, or it depends how many bleed areas you want to isolate. And you can connect to all of them simultaneously and create vacuum all at once. And on the right bottom side, there's the application for also subsea. This particular case, the subsea application, we had to tie into the pipeline on 40-meter depth. And on the right side, you see two yellow 10 feet containers. One is containing the process hose reel and the knockout vessel. And the other one inside, which you can't see right now, is the DBB saver and air compressor pumps. And on the back, we built a vent stack to vent off the gases. In the meantime, we have been very active. We have been engaged with almost all big majors in the industry. A few Americans are still missing on this list, but we are working on that, trying to explore the business and try to develop that over there in Americas. But we have done more than 1,000 DB safe deployments with more than 40 customers in 30 continents. In 30 countries and 4 continents. What we see typically, we are used for gas applications, although we have shown also that we can be used for liquids and LNG applications. And next, like Izomax also, we are very proud that we have had 0 HSE incidents, lost time injuries. So the conclusion of today is there are many advantages using DBB saver. We maximize the safety and the plant production. You have your lowest total cost of ownership. The safety enhancement is very simple. It's 0 leak rates. It's continuous proofing. It's a very fast also method to isolate any installation. And obviously, if isolation as simple as the use of the DBB saver, you can still remain the installation to be in operation. So you don't have to shut it down. You don't have to depressurize it. Being very cost efficient, obviously reducing a lot of costs for the operator. And as said already before, the DBB saver can be used in any diameter or pressure class. With this, I would like to finalize my meeting. I hope it was interesting for you. And if you have any questions, we can take it later.
Thank you very much, Evert. And in view of time, let's quickly hand over to Neil. So Neil, if you can start sharing your screen with the presentation. And while you do that, let me just remind everyone, if you have any questions for Evert, just like with Lynn, please type them in the chat and we will pick them up after Neil's presentation. Neil, over to you.
Thank you, Vincent. Good morning, everyone. At Stats Group, we're all about temporary pipeline isolations to reduce risk, save cost and time, and also reduce the associated emissions that come with the alternative technologies that are used for the types of projects we get involved in. And we've got 2 flagship technologies, the Bicep and the Remote Technoplug, and a case study to tell you about today. I'm Neil Mackay, Senior Business Development Manager from Stats Group. So today I'm going to go a little off-piste compared to normal. And instead of focusing on how the tools work and their functions and features, I'm going to cut through that quite quickly and get on to a case history concerning the replacement of a 30-inch valve on a mainline, a 30-inch mainline valve on a crude oil pipeline in Canada. So at Stats, there are 2 main technologies. There's the Technoplug and the Bicep. The Technoplug is a little more nuanced. We have a Remote Technoplug, which is a free swimming tool, which is pigged many kilometers, usually from the launcher, up to 2,000 kilometers. They cover the range 10-inch to 56-inch and up to 230 bar of differential pressure in a pipeline. They can be made to be 1.5D bend compliant, and they're prized for their safety. Where valves are not available or cannot be made suitably safe to use, because pigging in general is a very well understood practice in the pipeline industry. The remote plugs are a little more costly due to a higher level of technology than our tethered Technoplug range, which comes in two formats. They're either stem bar deployed for straight deployments up to 20 meters, or they are umbilically deployed and have some bend passage capability, but are limited to 60 bar by the umbilical. But the tethered plugs are prized for their ability to get into tight spaces and most commonly used to change pig trap isolations valves and completely avoid shutdowns. Our bicep technology was developed around 10 years after the remote Technoplug due to a call from the industry in the North Sea for an equal or greater level of temporary pipeline isolation to our remote Technoplug for non-piggable systems. So for a remote Technoplug, the pipeline has to be piggable. Pigging facilities are required, and the plug must be able to pass through essential features like valves and bends. The bicep initially was developed to accommodate non-piggable systems, but mostly it's used these days onshore in midline work where pipelines are piggable, but it's prized for its ability to, via a temporary bypass, keep the pipeline up and running. So no shutdown required. And it also provides a double block and bleed, complying with category 2 table that we saw in the previous presentation. Kind of mirroring the first presentation today, typically the work scopes we get involved in are repair or replacement of pipeline valves, replacement of pipeline sections, and also supporting tie-ins. So we're forged offtakes need to be inserted into a pipeline, and we're also getting involved in installation of above ground installations, which could comprise of metering stations, compressor stations, and or even installing pigging facilities. A number of operators worldwide also stock this equipment for emergency response, pipeline isolation and repair. I think it's important to have a look at the traditional techniques that would be used for midline work to contrast the advantages of our technology at STATS. Of course, if you have valves in a pipeline, then fantastic. They're simple. It's easy to isolate either side of the work location. No interventions required, no hot works required. It's quick and it can be cheap, but as we know, valves don't always seal due to wear and damage. And also due to our best efforts, sometimes we can't get them to seal. So often venting and draining of those sections as well between valves takes a long time, not least the environmental impact from venting methane, for example. Nitrogen displacement is another commonly used technique. These techniques will always be used, they will continue to be used, but they don't really make sense on large volume pipelines, higher pressure pipelines. So nitrogen displacement process where nitrogen is injected to displace methane that's vented or flared, or using pigs to displace liquids such as fuel oil, crude, etc. But again, managing all of that takes a lot of time and is cost prohibitive. Specifically for gas pipelines, the technique of cross compression is very common using recompression units. This is where gas is sucked out of an isolated section, or in fact an entire pipeline, and re-injected at pressure into an adjacent section. And there's usually a bit of venting and purging that goes on after that, and also returning the pipeline to service. And again, all of that takes a lot of time. Moving on to the case study. This was a 30-inch, 217-kilometer crude oil pipeline in Canada, required a valve replacement and a sectional replacement of around 18 meters. And in the image, you see the valve to be removed, which was located around 40 kilometers from the pig launcher site. Now, valves did exist in this pipeline. There was a valve 3 kilometers upstream and another valve 18 kilometers downstream, so about 21 kilometers apart. And the customer here knew, obviously, they didn't want to have to handle or manage the crude in that section. It would be much easier and simpler to provide local temporary isolations either side with the stats tools. Now, importantly, this project could have been done using 2 biceps with an integrated bypass either side. However, as we'll see on the slides coming up, that wasn't actually the best option. The operator here had a planned outage of 48 hours, and typically these pipeline operators have a couple of these per year. There's probably an extra day's contingency in there, but their request was to do this within 48 hours. So just stopping for a moment, you know, these operations are often done without an outage. We have the technology to do it. However, it doesn't always make sense from the operator's perspective to do things that way, as we will see. Looking at the satellite image on the right-hand side here, you can see a yellow cross. That's the valve to be replaced. Now, in this image, the orange dots represent the GPS coordinates of the girth weld, so you can see the pipeline route. And on the left-hand side, there was right of access and plenty space for an excavation and a bicep operation. So that typically involves welding of a T onto the pipe, performing a drilling operation, so a hot tap, to remove a coupon and then deploy a plug into the pipeline. So an excavation is required. There wasn't much space between the valve and the road downstream, indicated as short street on the image there. And so the customer wanted to proceed with a remote technoplug in that location. Now, importantly, and this is kind of a key point, there was plenty of space on the other side of the road, but often is the case onshore, the operators don't want to engage with stakeholders unnecessarily. So in this case, a farmer, during summer with crops there, negotiations for land access often mean project schedules are at risk. So if you can perform the work without having to interface with another party, it's advantageous. In this image, you can see a little bit of space between the valve and the road in the foreground. Definitely enough space to do a bicep isolation, but probably unnecessary amount of work and risk to the structure of the road, etc. When a remote technoplug isolation, which requires no excavation, was perfectly feasible. One of the key points here is the customer wanted to do this within 48 hours. So the excavation at the valve changeout site, the welded T installation and the hot tap, they can all be performed while the pipeline's up and running. And the bicep tool, when it was being installed onto the pipeline stack up, the offtake, the remote technoplug was being checked and loaded into the pig launcher. And the launch time for the plug was selected based on the pipeline flow rate to ensure that it arrived at the isolation location at the planned time for the outage. So these outages, they are planned to the hour. It's a very planned and organized event. So the remote technoplug was pigged through the pipeline, through where the bicep was deployed, of course, at that time. So the remote technoplug was pigged just downstream of the bicep. The pipeline was then shut down. The bicep was deployed and set. And then using a 3-inch hot tap offtake and product, local placement for precision placement of the remote plug locally on site was performed. And the remote technoplug was set, bicep was set, pipeline was depressurized. And then both the bicep and the remote technoplug provide double block and monitor for the plug. double block and bleed for the bicep. And we hand over an isolation certificate to the operator, which essentially confirms a safe isolation is in place, it's being monitored, and that's updated at the start of every shift. So safe to cut the pipe and replace the section. On the left-hand side, we see the new valve. So the valve was moved upstream, closer to the bicep. And on the right-hand side, we see the 18-meter section, which has been replaced as well. So summarizing, stats isolation tools can and often are used to completely avoid shutdowns to perform essential repair and maintenance, particularly the use of our bicep tool with integrated bypass. But I think the essence of this webinar is there are a lot of tools out there. It's important for operators to have the widest range of options, the widest range of tools available for all of the different scenarios that exist in the real world. And sometimes that means a mix. It means a bicep and a remote technoplug, or a bicep and even an AOGV, for example, or a bicep and a tethered plug, like we see in the image on the bottom right-hand corner of the screen. And I wanted to throw this in at the end because it's a nice little example of a real project in Malaysia where we used a tethered plug, 30-inch, deployed into a very short space between the isolation valve and the supply branch. So this pipeline remained up and running while the pig trap isolation valve was removed. And on the unpiggable portion, so the kicker line, for those of you who are familiar with pigging, we used an 8-inch bicep to change the kicker line valves. So both of these isolations were undertaken at the same time with different tools on the piggable and unpiggable portions, crucially while the pipeline remained in production. But important to mention that where shutdowns are actually unavoidable, or where strangely sometimes they are selected by operators, the use of these tools greatly reduces shutdown time versus the traditional techniques that I mentioned earlier in the presentation. Thank you very much.
Thank you, Neil. And that leaves about 10 minutes for the Q&A. So if all of you could switch your cameras back on, maybe Neil, you can stop sharing so everybody can see you all clearly. I will pick up some of the questions in no particular order. I see some of them are already nicely linked to also a couple of things that you actually just mentioned, Neil. But let me just read them out as they came in. So the first question is from someone that's asking, are there scenarios where the DBB Saver and Izomax technologies are complementary rather than competing? And I guess we could stretch that because actually this question came in while you were still presenting, Neil. So maybe it's actually a broader question, right? If somebody, after having seen this, needs to make a selection, I guess we can include also the stats tools in that. You already hinted at one scenario, Neil, or Evert or Lynn. Are there any other scenarios that you already have fresh in your mind where actually the tools that you provide are complementary?
I can answer this one if that's okay. So one of the reasons you would look to deploy a remote technoplug, for example, would be to replace a valve. There may be one, there may be two. Maybe one of them's in good condition and the other's not. But the difficulty sometimes arises where it's not safe to open the pig trap door because the valve's passing significantly. So by using the DBP Saver and getting access to the trap to launch the plug, to set it and keep the pipeline up and running while the valves are, going through a more robust overhaul, shall we say. That's one example where the two technologies can be complementary.
Yeah, that's correct. I would like to step in there. It's something we've done in the past already together with Stats, and actually we're looking now in the North Sea area, again to replace the ESDV valve, which is leaking, and we're using one of the stats tools, but we are creating a safe working zone. So that's really a nice, we are really complementary to each other.
And I think
Lynn?
for Lynn as well, you know, there was a scenario last year where, you know, the bicep, for example, can't be deployed where there are flanges. You know, the process begins with a clamp or a T. The AOGV needs flanges, but there was a scenario where there was a repair clamp which needed to be cut out and replaced on a T. On one side of the T there was a suitable valve. On the other side of the T there was only the option to use a bicep, and on the other side there was the only option was to use an AOGV. So there are scenarios where the technologies really do complement one another, where one can't be used and the other can. And I think that's a really important point. Like I said, the essence of the webinar is, from an operator standpoint, don't you want all the tools available to you so that you can select the right one for the requirements of the scope?
Great. Lynn, anything to add to that?
I was just going to say, well said. That captures it exactly. Complementary technologies, and often, yes, it is circumstantial, and so the solution needs to fit the application, and that doesn't mean that we can't work together. We have not yet, but there are many opportunities, and we have looked at various applications of incorporating one or more technologies alongside the AOGV, and so watch this space.
Yeah, I think my own interpretation is that, I guess, if there is something that differentiates it, what I think the stats tools are mostly focusing on pipeline systems, whereas the Izomax and the double block and bleed saver also have quite a number of implant application. Is that a correct interpretation, or do you also work in implant?
Yeah, we're very much working topside in platforms, especially historically. It's just the volume of pipelines that exist in the world means that there's a lot more opportunities for the use of our tools onshore. But historically, I mean, almost exclusively for a long time, our work was focused around terminals and offshore platforms, which we continue to work in daily around the world.
Okay, let's move on to the next question. Interesting one, actually. How should operators decide between temporary isolation, enhanced valve-based isolation, or full positive isolation? That may be one too long to answer here, but
yeah, I think it depends on all the complete situation. It's something you can discuss with either of us, where how the operations are planned, what the issue really is. So for me, it's really hard to answer this question. It really depends case by case what the best solution would be, and it can be, again, a combination of the both, or two or three, mostly two companies. But yeah, I would say it depends, and reach out to one of us to discuss, because we know each other's technology, and we also are, I think, completely honest and open to discuss, okay, in this particular case, it would make sense to work with the Izomax tool or the stats tool or the B saver. Most of the time what we see is that we are actually complementary, or even not really competing. There's a small overlap in what we are doing, but we have our own advantages, and I think depending on the situation you're in, we can look what the best solution would be.
Okay, thanks. Next one is actually specifically for you, Evert, for Valvetight, related to the comment that you made. Since your tool is one size fits all, actually it's a double question. Do you work with a lease or buy setup, and do you always require Valvetight operators, or can it also be operated by your own team?
Yes, good question. I forgot to mention, but we typically work under a lease construction, and we lease our tools for a fixed period of time, or we have frame agreements from 1, 2, 3, or 5 years. And we're even talking to customers now to set up a frame agreement for 10 years. So that's how we are working. So it's a lease construction. And the second question, we work with our own operators. Typically, we send 2 operators because we need to be in control of our own machine and we want to guarantee the high quality we are delivering. But we do have examples of customers which are using the DBB saver that much that they use it on a weekly basis. So we have trained their operators how to work with the DBB saver. And basically, they are operating their own DBB saver, which they have leased for 5 years, but they use it on a weekly basis. So it's part of their process now, because they had an accident in the past, and they said, we want to make sure that on every isolation, we use the DBB saver to make sure we can work safely. Hence, we trained their personnel, and they operate the DBB saver themselves. But typically, we send our own operators.
Okay, thanks. And next question is, I guess, again, for all of you. What isolation integrity checks are possible once either solution is deployed, and how is leak tightness verified?
We probably all have to answer that individually.
Yeah, well,
It's different.
Yeah, if you can.
I'll start then. I'll keep it concise to allow Lynn and Evert to answer. But we follow a seal testing process. So each seal is independently leak tested in the correct direction, equal to or greater than the pipeline pressure, and an hour on each seal and then a hold period, and we sign an isolation certificate. And our seal testing process is based on the isolation table that you saw in the Valvetight presentation. So we're trying to comply as much as possible with the HSE regulation for safe isolation of equipment and plant. And the remote technoplug provides a double block and monitor. So there is very small volume of pressure inside between the 2 seals, and it's monitored. And the bicep, we have a 0 energy zone between the seals, access to an annulus between the 2 seals, which is routed to a safe location and is monitored as well during the isolation. And the tools are also self-energized by the gas pipeline pressure. So they're hydraulic, but if the hydraulics were to fail, which has never happened, then the tools are self-energized by the gas or oil pressure in the pipeline.
Okay, thanks, Lynn.
A quick one from me. We have various touch points throughout our operational sequence, and that means that we are often and continually doing leak tests. And this is always 10% above the operational pressure at site. And so once that is verified, we will then continue to the next step of the process. So we'll always ensure that we are remaining leak tight at various points throughout the execution. All our tools are certified by the PED certification, as well as going through rigorous third-party testing and being cycle tested and assembled at workshop prior to execution.
From my end, we pull a vacuum. We have set points, for example, -300 millibars up to -50 millibars. And within those set points, we constantly create and monitor and control the vacuum. So during the whole time we are connected to the bleach section, it's continuously monitored. The vacuum is continuously monitored. And in case we are out of our set points, alarms will be raised. So once the DBB saver is on, you'll have a report in the end where we can show that this continuously, we had a vacuum during all operations. And because of that, you were working all the time safely behind the valves.
Okay, thanks. Yeah, so of course, slightly different based on the different physical setup of the system. Also, with answering that question, we've actually reached the end of this webinar. It's 11 o'clock sharp here in the Netherlands. So I would like to wrap it up by thanking the presenters for today. Thanks everyone that joined us today for this webinar. The next webinar will be in 2 weeks' time, so check out the technologycatalog.com website if you want to register for that one. It will always also be an integrity related topic, and hope to see you then. And have a great day. Bye bye.
Thank you.
Thank you. Bye
Bye-bye.
bye.
Bye-bye.